I'm going to begin with the no calculator part of the 3.1 through 3.4 review. We are beginning with the no calculator part. These are complex numbers. And yes, number one is actually 2 minus 7i quantity squared. Well, what does that square mean? It means that 2 minus 7i is written twice. And then you're just going to FOIL like you did since you were in Algebra 1. 2 times negative 7 is a negative 14i. Negative 7 times 2 is a negative 14i. Negative times negative is a positive. 7i times 7i is 49i squared. Combining like terms, we get 4 minus 28i. And you remember when we did I squared and we defined I squared is a negative 1. Replace negative 1 for I squared. In standard form means the imaginary number comes last and the real number part comes first. Negative 49 plus 4. Negative 49 plus 4 means that I'm going to subtract 4 from 49, but 49 is further away, so I take the sign of the larger number, or larger absolute value. Negative 45 minus 28i. Problem 2 is just a combining problem. You combine the real number parts. 2 plus 4 is 6. Combine the imaginary number parts. Remember, this is just like an x, 1x. So negative 3 plus 1 is a negative 2i, and you're finished. With problem number 3, you want to make sure that you distribute this negative. 9 minus 5i minus 3i plus 6. And then combine like terms. The real number part is 15, 9 plus 6. The imaginary number part is negative 5 minus 3, which is negative 8i. Problem 4 is just a product. We're multiplying, and we're going to FOIL that out. First times first, outer times outer, inner times inner, minus 2i squared, last times last. Combining like terms, 6 minus 1i minus 2, replace the I squared with a negative 1, makes these plus plus. 6 plus 2 is 8, minus I, or 1i. On problem 5, you're dividing. And to divide a complex number, you're going to multiply by the conjugate of the denominator. That means, look at your denominator, the bottom one. Change the middle sign. 5 plus 3i then goes to the right of both the top and the bottom of the fraction. And now you're ready to FOIL. 7 times 5 is 35. 7 times 3i is 21i, minus the 55i, minus the 33i squared. I'm also going to FOIL the denominator. 5 times 5 is 25. 5 times 3 is 15i, minus 15i, minus 9i squared. And then I'm going to start combining like terms. 21 minus 55. 55 is bigger than 21. Since my signs are a positive and a negative, I'm actually going to subtract my number. 55 is further away from 0 and it's negative, so that's a negative 34. 35 minus 34i minus 33, and I'm going to replace the I squared with a negative 1. In the denominator, I have 25 minus 9, and I'm going to replace the I squared with a negative 1. A negative times a negative is a positive. 33 times 1 is 33. 35 plus 33 is 68. In the numerator, 35 plus 33 is 68, minus 34i I. In the denominator, I have 25 minus 9 times 1 is 9. Negative times a negative is a positive. 25 plus 9 is 34. 68, 34, and 34 are all divisible by 34. 68 divided by 34 minus 34i divided by 34. 68 divided by 34 goes in 2 times. 2 times 4 is 8. 2 times 3 is 6. 2 minus I. On problem number 6, this is what is the conjugate of the above problem? What is the conjugate? Well, it's the denominator with the middle sign only changed. So on problem 6, 6 plus 3i. Now on 7, I'm going to add some things. I'm going to add the square root of negative 50. You don't have this one. And this is I raised to a negative exponent. Let's look at the I to the negative 6. To get rid of a negative exponent, you move it into the denominator, and it becomes positive. We have a fraction. We have I squared, I squared, I squared. I squared is a negative 1. So if I replace negative 1 with all the I squares, a negative times a negative is a positive, and the answer is a negative 1. The other way you can do this is you can say 6 divided by 4 goes 1 time with a remainder of 2. These I squareds, there's 2 of those, that's I to the 4th, which is 1 times I squared, which is a negative 1, and you get the same answer. It just depends on how you remember it. On 50, we're going to break 50 down into 25, the perfect square, and 2. The square root of a negative 25 is 5i. The 2 stays underneath the radical, root 2. Now, the way I broke down the I to the 6, I really don't want to do that with I to the 19. So I'm just going to take 19 and divide by 4. 4 goes into 19 evenly 4 times. 4 times 4 is 16 with the remainder of 3. I to the 19 then is the same as I to the remainder of 3. Remember, if I have 4 I to the 4th, I just have 4 ones. 1 times 1 times 1 times 1. Well, 1 times any number is itself, so 1, and that leaves I to the 3rd. I to the 3rd is I squared times I to the 1. I squared is a negative 1 times I, or negative I. On problem number 9, you're given the equation negative 2x squared plus 6x plus 9, and they want you to find the vertex. The formula that I told you that you had to have memorized to find the vertex is the opposite of b over 2a. The vertex is the minimum or maximum of the problem. In standard form, the number in front of the x squared is a, the number in front of the x is b, and the number by itself is the constant c. The opposite of a positive 6 is a negative 6 divided by 2 times negative 2. A negative divided by a negative is a positive, and both of these are even, so I'm going to divide them by 2. So the vertex is 3 halves. Now, that gives me my axis of symmetry, and I need to find the y value for my vertex. So I'm going to go back into my function, negative 2, and in place of x squared and in place of x, I'm going to put 3 halves. 3 halves squared means I have a negative 2 over 1 times 3 halves times 3 halves. This 2 can divide that 2. 3 times 3 is 9 over 2 plus if I put 6 over 1, then 2 divides 6 3 times. 3 times 3 is 9, plus 9. 9 plus 9 is 18. And 9 halves is a fraction, so I need a common denominator. Now, there's two ways that you can do this. What is half of 9? Well, that is a negative 4.5. So if you know that that's a negative 4.5, you can go ahead and put a negative 4.5. 18.0 minus 4.5. Line up your decimals. 5 from 10 is 5. There's the decimal. 4 from 7 is 3. And you get 13.5. So the vertex is the point, 3 halves, and 13.5. Now that's one way you can do it. If you're not sure what this 9 halves is, you can go ahead and change. What did you multiply 1 by to get a 2? Well, 2. 2 times 18. If you're not sure what that is, you can always come to your scratch paper and multiply it. 2 times 8 is 16. Carry the 1. 2 times 1 plus 1 is 3. 18 times 2 is 36. When you have denominators that are the same, you keep the denominator and you add or subtract the numerator. 9 from 36, we're just going to subtract and line up. And you get 27. So one answer in decimal form is 1.5 and 13.5, or 3 halves and 13.5. The other answer in fraction form is 3 halves and 27 over 2. Both of those are exact answers and are perfectly okay. We're going to find the zeros of the function. That's 10. The zeros mean we need to use the quadratic formula. Our a, b, and c have not changed. The opposite of b plus or minus b squared minus 4 times a times c, all divided by 2 times a. Going with the orders of operation, the grouping symbols first, b, 6 squared, 6 times 6 is 36, minus 4 times a negative 18. I'm going to go ahead and say 9 times 2 is 18. It does not matter in what order you multiply those together. You could say a negative 4 times a negative 2 is a positive 8 plus 9. Negative times negative is a positive. 36 plus 72 underneath the radical. Keep the rest of it. Negative 6 plus or minus the square root of, again, if you don't know what 36 and 72, come over here and do 36 plus 72. Line those up, 108. Divided by a negative 4. Now, what's a factor of 108? 108 can be a couple of different things. One of them is 9 times 12. I'm going to rewrite my 108. Underneath the radical is 9 times 12. I also know that 12 has a perfect square of 4. 4 times 3 is 12. Over here, I'm going to say negative 6 plus or minus the square root of. What is the square root of 9? It's 3, so it goes in front of the radical. What's the square root of 4? 2. It goes in front of the radical, and the 3 stays underneath the radical. Negative 6 plus or minus 2 times 3 is 6, radical 3. And I'm going to go ahead and break these apart to negative 4. Negative divided by negative is positive. I'm going to cut them in half because they're even. Plus or minus 3 halves over radical 3. Now you don't have to cut them in half. You can leave it 3 plus or minus radical 3 all over 2. On problem number 11, it says give the interval over which the answer is increasing and the interval over which it is decreasing. Now, in problem number 9, we found the vertex. So to write 11, it's going to be relatively easy. If we understand that the parabola is pointing down because it's a negative x squared. If my parabola is pointing down and my vertex is that 3/2 and 27/2, the interval in which it is increasing is coming from x values, remember, negative infinity to 3/2, and decreasing from 3/2 to infinity. Problem 12 says, write the equation of this parabola. How has this parabola shifted, transformed from the original? It went left 3 and up 4. From our transformations sheet, first off, we know that it is a parabola, which means that it's quantity squared. The plus 4 is pointed up. It shifted to the left, which means inside the function it is the opposite operation. It's also turned upside down. There's something else I need to talk about. Do you see the stretch factor? To get to the next nice point, I had to go down 2 and right 1. That means I have a stretch by a factor of 2, and the turned upside down means I have a reflection.